Ladies and gentlemen, what a pretty spring picture that is. Well, let's get into the pretty essential questions, shall we? Here we go. This is section 3, chapter 10. This is the first video I'm doing here, video lesson. And there's two things here that's going to happen in this video lesson that you're going to master. How do you graph circles? That's one. And how do you write the equation of circles? So that needs to go into your notes for sure. Right there, the essential questions, really, how do you graph? And how do you write the equations of circles? Well, let's dive into this first. A little stroll down memory lane, people. You can jot this down in your notes too. Draw a quick little sketch of an x and y axis. And these four equations right here, or functions as I put, if I put f of x over here. But what did these guys look like whenever I graphed them on the coordinate plane? Now, I'm going to change a bunch of these because they're all looking exactly the same to start with. But let's do this. Let's say that this one, I asked you to graph this guy right here. So what would this one look like on the coordinate plane? Well, if I didn't do anything else and it was just x to the first power, this would be my y-intercept, remember? So at 9, let's say it's right there, at 9 would be where the actual graph would cross the y-axis. And the slope is just 1 over 1. So it's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So it would just be a straight, so not going to be all that straight, but get the idea. It would just be a straight line like that, kind of, because it's linear. That 1 right there, that exponent of 1, means it's linear. It looks just like a line. And it's a positive slope, so it's going up. If it was a negative slope, of course, it'd be going down this way. So, let's go down to this one. What if we actually put a little 2 up here now? Uh-oh. Now we're talking about a quadratic equation. And yes, that looks like a parabola. And at 9, let's say it again, right here's 9. At 9 would be where the vertex is actually crossing, according to this, crossing the actual y-axis. It's the y-intercept, if you will. So the vertex is at 0, 9, and it's a parabola, so it would just look like this. A nice little U-shape comes down here, boing, bounces off of there. It was a nice parabola. Wow, good job, Mater. So there's your parabola. Now, if this was a negative a value, remember, in front, the parabola would just kind of flip down, and it would be an upside-down U. Regardless, that's what a squared function equation look like. So linear was straight line. A quadratic, a squared one, was a parabola. Okay, let's keep going. What if we had one that was a cubed? Uh-oh, back to your remember banks. Remember now. Yep, since it's a positive a value, it looked something like this. It was a particular S shape. Oh, that's an ugly one. Wow. Let's redo that. Wow, wow, wow. So it would look like this. Now, it might not have maybe, humped like that right there. Maybe not turned as much, but it did definitely turn 3 times. So 1, 2, 3 times. That's what it was with we had a cubed function or equation. And then the last one is if we had something like this. If we had it to the 4th power, remember, that one right there looked somewhat like a W. And maybe it didn't look quite that nice of a W. But maybe sometimes it come down here and just kind of flatten out a little bit, like that. It's a nice one, actually. So not quite a parabola, but something like that. And remember, if the a value was negative, that meant it just went upside down. So it was either an M or a flattened out U-shaped. So all those are great. We all remember those. Linear, quadratic, cubic, quartic. But here's the kicker. What happens if I throw this one to you? What would this one look like? Whoa. X squared plus y squared equals 9. Completely different. And check this out. This little guy here says, of all people, I feel like I should know. And the little circular smiley face dude says, you'll see why that actually is going to come into play here shortly. Here's what I've done for you. You should do this in your notes too. Let's take this x squared y squared equals 9 and actually put it on a coordinate plane. Let's graph it. So let's make an xy table, an xy chart. I've started with 0 as x. If I put 0 in here for x, all it means is this. I put 0 right there. So I get 0 squared plus y squared equals 9. And I solve this. Well, this is gone. 0 squared is gone. I would have y squared equals 9. And what I have to do, you got it. Square root both sides, square root both sides. Don't forget, it's plus or minus. So I'm left with y equals positive or negative 3. So if I did that, and I put that over there in my little xy table, xy chart, I'd have 0, 3, or 0, negative 3. Well, check this out. If I put these points on the coordinate plane, 0, negative 3, that's down here. And 0, positive 3, that's up here. So there's those points. Now, if I keep going, here's what happens. What if I put -3 in there? Well, that gives me 0. Actually, I've already done that. So if I put -3 in there for x, that actually would give me a 0 if you solve it. And I did the rest of them too. I kind of filled out this chart for you. I just kind of kept going and put -2, -1, 1, 2, and 3. I put them all in there, and I've calculated them for you. So you just need to copy this into your notes, and you can go back and calculate them if you want. But they all turn out to be plus or minus, and I made them decimals so it's easier for us to kind of graph on here. But they would just be simplified square roots if you had it, or just a regular old square root. But it is plus or minus. But here's why I did all this for you. If I now take and put my dots on there, so let me do these again. 0, 3, 0, -3. Let me take this one. -3, 0. That's right there. Let me take this one. 3, 0. Well, this isn't looking like a parabola. This isn't looking like a straight line. This isn't looking like an S or even a W. Let's keep going. -2 and positive 2.2 is somewhere about right there. And the negative one, -2, -2.2, somewhere about right there. Okay? Same thing happens with 2. Positive 2, that's right over here. So positive 2, positive 2.2, and positive 2, -2.2. Haha. You're getting it, I think. So I just did those. So let's do 1. 1, positive 2.8. That is 1, positive 2.8 up here. 1, -2.8 down there. So that's this one. Whoops, sorry. That's this one. So now if I do -1, positive 2.8, that's up here. Look at this thing. Now if I connect all the actual dots. Wow, look at that shape. This is going to be funny. I don't know how it's going to look when I graph it. If I connect all of these dots. La 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 la. Forgive this. Wow, it's kind of hard to draw a shape like this with a mouse. Not bad though. Well, what did we just create? You got it, my friends. A dandy little circle. Haha. So I hope your circle looks better than that. But if I connected all those dots, it looks like a circle. And by the way, check this out. Here's why my little friend was supposed to be on there. Because, yes, he's the reason why he says I should remember this or I should know this. Because he is a circle. Okay. Anyways. So here's what you need to write for sure into your notes. This right here, big time, the standard equation of a circle with the center at the origin. I'd highlight that for you for sure. Center at the origin. We're going to talk in another video about the center not being at the origin, where it's shifted a little bit, up, down, left, right, whatever. But here's what you need to write in your notes. The standard form of the equation of a circle with center 0, 0 and radius r is as follows. That right there is your standard form of the equation of a circle, centered at the origin. And there's a great example right here. Oh, check this out. It's the same one we just did. Huh. And if you go back and look at the picture, rewind the video, you'll see the radius length was 3. So how do we apply this then to questions where it just gives you a graph and says, hey, match them up, or actually to graph them? And you're going to be asked to do that. Well, check this out. I've given you 3 examples. This particular standard form of the equation is given to you, but it's not quite written like this because this says r squared and that says 16. Well, if I rewrote it in standard form, I'd have x squared for sure. I'd have y squared for sure. And I'd have to rewrite this 16 as 4 squared, as something squared. Something squared. Well, that then, ladies and gentlemen, happens to be my radius length. Well, which one does that match up with? Not this one. Oh, here it is. So the radius length here is 4. So this one would be the correct graph that goes with number 1. Well, let's go over to this one. If I rewrote it, my radius length would be 6. So which one's that one? Oh, that one happens to be this one. Yeah, buddy. So this one would match up with number 2. Lovely. Well, how about this one? Wait a minute. How do I write 3? Whoa. How do I write this one in standard form? I got x squared. I got y squared equals, well, how do I write that? As something squared, but I need it to go to a 3. Well, here's how you do it. It's the square root of 3. So that right there, guys, as weird as it is, that's the radius. And what is that? Well, it's a decimal, and here's what it is. Boop. So this guy right here matches up with number 3. Awesome. Now you're not going to have to match them up this way. You're actually going to have to graph them. But you have to find the radius length first, the radius length first, the radius length first, whatever squared, that R thing, and then graph them. Lovely. So back to the essential question. We've taken care of how do you graph the equation, or a circle. So now the question is write the equation. How do you write the equation of circles? And remember, here's the scoop. We just talked about this. This is your standard form of the equation of a circle centered at the origin. And I'm going to be very real with you. The only thing you guys really have to find is the radius length. As soon as you find the radius length, and there's two ways to do it, but as soon as you find it, just plug them in, square it, and you're done. That's pretty cool. So this example needs to go in your notes for sure. Write it exactly like it is. Write the standard form, that's this right here, standard form, of the equation of the circle that passes through -8, 6, and whose center is the actual origin. So all of this is very important wording. Origin, that's cool. It's going to be centered there, going through -8, 6. So wait, let's do that. -8, 6 is right there. So I need a circle here. It comes bouncing in. I need that circle, great, to pass through -8, 6 right there. So I need, though, to write my equation of this circle like that. And remember, I just said this. This is all I got to do. I just have to find the radius length. That's it. My goal is to find that. Well, wait. If I put -8, 6 over here on the graph, -8, 6, and my center is the origin, watch this. If I drew that thing right there, what is that, guys? That's the radius. Oh, so I got to find the length of that, aka the distance between this point here at -8, 6 and the origin 0, 0. So one way for sure to do it is the distance formula. This would be one of your x1s and y1s. The origin would be your x2 and y2. Plug it in appropriately to the distance formula, and you'll get the right answer. And then plug it in and you can finish it up. I'm going to show you this way, though. I'm going to show you the same way, where this is going to be the x, this is going to be the y. My point still is over here, but all I'm going to do, guys, is this. Again, remember my goal. It's going to find the radius. I'm going to take this -8, which is what x is, and I'm going to plug it in right there. That's right. And I'm going to take this y, which is actually 6, and I'm going to put that thing in right there. Why would you do that, Mr. Modder? Keep in mind, and look what I'm doing. You need to do the same thing. Make sure you put parentheses around it. I'm putting -8 in for x, and I'm squaring it, plus whatever y is, which happens to be the 6. Bam. And I'm going to put a parenthesis around and square it, and I'm left with, or on the right side, just the radius squared. Back over here, just so you know, I need to make sure I clear this up. The reason I'm able to put this point in there is because I'm writing the equation of this circle, and -8, 6 is on the circle. Don't just take any random point, and don't take the origin. You could take this point up here if you knew it, or this point over here if you knew it for sure. But I know for a fact -8, 6 is on the circle. It told me that. That's why I'm taking that point. So let's do some algebra. -8 squared, be careful when you plug in your calculator. It gives you positive 64. 6 squared is 36, and I still have r squared over here. That's cool. Yeah. So when I solve this, keep on going. It's 100 on the left side equals r squared. Forgive the writing. So I take the square root of both sides to get rid of the actual square. So these cancel. But keep in mind, remember, it is plus or minus. So I actually have, the square root of 100. It's just 10. So I have positive or negative 10 is my radius length. Now again, I'm looking for the radius between here and the origin. That guy right there. So which one is it? Is it 10 or -10? Well, you can't have a -10 as a distance. So you disregard the -1. If I could erase it, I would. And my radius length is just 10. So since my radius length is 10 that I just found, the radius is 10. All I need to do, since that's the radius, I plug that bad boy right in there. So I get x squared. This is my standard form of the equation of a circle centered at the origin, right there. And as I said a little bit ago, 2 minutes ago, all you're looking for is the radius. Found it? So that's 10 squared. Don't leave your answer that way. You just got to do this. Finalize that. So my final answer here would be x squared plus y squared equals 100. Yeah. That is the equation of this circle right there, where the radius is 10, and notice this up here is actually 10. Sorry, here's my phone again. 10, 10 there, and 10 there. So they are all correct, all passing through 10. 10, 10, 10, and 10. There's your equation. Let's do one more quick example. Stick with me. Alright, next example. Here we go. Write the standard form of the equation of the circle that passes through the given point and whose center is the origin. There's the given point. So at negative 2, 4, I need a circle to cross there to bounce in. Awesome, there it is. And again, excuse me, remember, this is what I'm looking for. The standard form of the equation, x squared, y squared, r squared. I'm just looking for the radius length. So, well, two ways. Again, you can use the distance formula, or just take this x and that y and plug them into the appropriate spots and solve for r. I shall do that. Negative 2, when I put it in there, I'll put a parenthesis around it, just like you should. There's my x coordinate. My y coordinate is 4, so it's plus 4 squared. Lovely. And that equals my radius length. That's what I'm looking for, because I got to plug that in here. So negative 2 squared is 4. 4 squared is 16. Ooh, look at this. Which is going to give me, I'm going to switch this around. Now just keep it this way. 20 equals r squared. I take the square root of both sides, disregard the negative because I can't have a negative length. So what I have is the radius length, whoa, is the square root of 20. Well, that's weird. Not really. That's the radius length. So since that's r, guys, then I plug that right in there for r. Sorry, I slipped. So that's cool. So let's do that. That means this. I'm going to have x squared. I'll write it down here. X squared plus y squared equals the square root of 20. That's what the radius length is, the square root of 20. All of that thing is squared because that's the radius up here. Well, wait. Square root of 20 squared just means they cancel. So my answer for the standard form of the equation of this particular circle passing through negative 2, 4, centered at the origin, is right there. X squared plus y squared equals 20. Ba-bam. Study these, practice these bad boys. We'll see you in class. Looking forward to it. Later.